We are going to dig into an instructional strategy that supports IOA 2B, where students add and subtract within 10,000. The compensation strategy allows students to become efficient mathematicians, and we are going to talk through that using this problem. You can see I've done the work ahead of time. My problem is about tickets being sold on a Monday, Tuesday, and there were a total of tickets sold. There were 5,356 tickets sold on Monday. We don't know how many tickets were sold on Tuesday, and there were 8,000 total tickets sold. So when we are missing a part, we are subtracting. And you can see here, we will be subtracting across 3 zeros to the thousands place. That can be very confusing for students. So we want to make this an easier problem to deal with for our kids. And the compensation strategy allows us to do that. Let me show you what I mean when we are using the compensation strategy. And we are going to use a smaller problem so that we can talk through this thinking. Let's say we had the problem 8 minus 6. And I wanted to represent that on a number line. So draw this real quick. 5, 6, 7, 8. Okay, when I subtract 8 minus 6, I can jump back to the 6 and determine how many jumps I made, and that is the difference or distance between these two numbers. So from 8 to 6, there is a difference or distance of two numbers, a distance of 2 or a difference of 2. Well, let's say I didn't know my 8s very well and I wanted to adjust the problem. So I could remove 1 from the minuend, the first number in a subtraction problem, and make that a 7. I can remove 1 from the menu or the subtrahend, the number we are removing, and make that a 5. So I've just adjusted my numbers. I've removed 1 from the 8 to make a 7 and a 1 from the 6 to make a 5. Let's see if we keep the same distance or difference between these two numbers. So if I start at 7 and I jump back to my 5, I can see there is a difference or distance of 2. So the compensation strategy allows us to keep the same distance between two sets of numbers or the same difference between the two sets of numbers. Let's apply this thinking when working with numbers, the minuends, the numbers we are subtracting from that have a whole bunch of zeros. So let's remove 1 from 8,000 and we get 7,999. And then if I remove 1 from the subtrahend, the number we are removing, that is 5,355. So we've removed 1 from each of our numbers, and now we can solve that without having to regroup across zeros. To scaffold your students if necessary, you can completely build, using your new place value discs, the new whole of 7,999. Starting in the ones place, 9 ones minus 5 ones, we can completely remove 5 ones and see that we are left with 4 ones. But for our purpose today, we are focusing on the abstract thinking of this strategy known as the compensation strategy. So 9 ones minus 5 ones, like we found on our plate with our place value discs, is 4 ones. 9 tens minus 5 tens is 4 tens. 9 hundreds minus 3 hundreds is 6 hundreds, and 7,000 minus 5,000 is 2,000. So what we figured out is the difference or distance between 7,999 and 5,355 is 2,644. This difference between these two numbers would be the same difference between 8,000 and 5,356. Okay, you can find more out about the compensation strategy on the 2B small group move document for this IOA, and you can find it either on the pacing guide or on the econ unit page.